sample test for difference of proportion. Okay. So last, I think, single mean we have discussed. Now difference of mean. Last example, 14 number example, which we have discussed. Okay, so test of significance for the difference of means, large sample. Okay, so here if you have given two samples x1 and x2 for independent large random samples with size n1 and n2, here n1 and n2 greater than 30. Okay, then we call it large sample, drawn from two populations with mean mu1 and mu2 and standard deviation sigma 1 sigma 2. Then the working rules is, first of all, null hypothesis, mu1 equal to mu0, that is two samples have been drawn from two different populations having the same mean and equal standard deviations. Okay. Alternative hypothesis, mu1 not equal to mu2, or mu1 less than mu2, or mu1 greater than mu2. And level of significance alpha, test statistics z. So here this is the first, when populations standard deviation sigma 1 and sigma 2 no one. Okay, standard deviations no one, then you have to use this statistic x1 bar minus x2 bar upon under root sigma 1 square upon n1 plus sigma 2 square upon n2. So this is the first way you can calculate the statistic if you have given two different standard deviations. And when population standard deviation sigma 1 sigma 2 not given, then sample standard deviations s1 and s2 must be given. So x1 minus x2 bar upon under root s1 square upon n1 square plus s2 square upon n2 square. Okay. Then we have to find out the critical value z alpha of z from the level of significance. Okay, whatever you have given, 0.05 or 0.01, and then you have to compare this value with mod z. If mod z less than z alpha, then the null hypothesis is accepted, and mod z greater than mod z alpha, then null hypothesis is rejected. Okay. And for any mod z greater than 0 without mention of any level of significance, null hypothesis 0 is rejected. Okay, in our presence, fine. And now confidence limits. We also discussed for 95% of confidence limits, and formalize here x1 bar minus x2 bar plus or minus 1.96 under root sigma 1 square upon n1 plus sigma 2 square upon n2. And 99 confidence limits, x1 bar minus x2 bar plus or minus 2.58 under root sigma 1 square plus n1 plus sigma 2 square plus n2. So, and sigma 1 and sigma 2 are not known, then we use s1 and s2. Okay, simple standard deviations. Here examples. Test the significance of difference of the means of two normal populations with same standard deviations from the following data. Okay, टू डिफरेंट नॉर्मल पॉपुलेशन, दो डिफरेंट नॉर्मल पॉपुलेशन हमें दी गई है और उसके विथ सेम स्टैंडर्ड डेविएशन, पॉपुलेशन की स्टैंडर्ड डेविएशन सेम है. अब यहाँ दो सैंपल है हमारे पास, साइज n इज इक्वल टू 100 एंड n इक्वल टू 200. दो सैंपल है, उसके मीन दिए हुए हैं और स्टैंडर्ड डेविएशन दिए हुए हैं. तो जो डेटा दिया है वो पहले लिख देते हैं, n1 n2 x1 बार x2 बार एंड x1 एंड x2 ये दिया हुआ है. और हमें क्या करना है, टेस्ट ऑफ सिग्निफिकेंस डिफरेंस बिटवीन द मीन of two normal population with same standard deviation. So null hypothesis क्या होगी, mu1 equal to mu2, मतलब कि there is no significant difference between two means. Standard deviation तो same है, वो तो बता ही दिया है, पर इसमें कोई डिफरेंस नहीं. हम रिजेक्शंस के तौर पे null hypothesis कंसिडर कर रहे हैं, तो यहाँ हमें टेस्ट ऑफ सिग्निफिकेंस फॉर डिफरेंस बिटवीन द मीन ऑफ टू नॉर्मल पॉपुलेशन विद द सेम स्टैंडर्ड डेविएशन ऑफ द फॉलोइंग डेटा, वो टेस्ट करना है. तो नल हाइपोथेसिस होगी यहाँ पे mu1 इक्वल टू mu2. तो अल्टरनेटिव क्या होगी, mu1 नॉट इक्वल टू mu2, मतलब दोनों इक्वल नहीं है, ट्रू टेल होगी. लेवल ऑफ सिग्निफिकेंस 0.05. टेस्ट स्टैटिस्टिक अब आपको x1 बार x2 बार दिया हुआ है, सैंपल स्टैंडर्ड डेविएशन एंड सिंपल स्टैंडर्ड S1 एंड S2 दिया है, तो इस हिसाब से फॉर्मूला हमारी होगी z इक्वल टू x1 बार माइनस x2 बार अपॉन अंडर रूट s1 स्क्वायर अपॉन n1 प्लस s2 स्क्वायर अपॉन n2। डेटा पुट करते हैं तो हमें क्या मिल रहा है, z इक्वल टू माइनस 3.31। तो पहले तो मोड z लेंगे 3.31। अब क्रिटिकल वैल्यू फाइंड करेंगे। क्रिटिकल वैल्यू कहाँ पे, कोई टेस्ट ऑफ सिग्निफिकेंस नहीं दिया है तो बाय डिफॉल्ट 0.05 मतलब 5% टेस्ट ऑफ सिग्निफिकेंस हम लेंगे। तो उस पे वैल्यू है मेरी मोड z 8.05 इज 1.96। तो क्या कह सकते हैं, मोड z ग्रेटर देन एब्सोल्यूट वैल्यू ऑफ z 0.05, the null hypothesis is rejected at high level of significance। ओके, यहाँ पे क्या मिल रहा है, मोड z ग्रेटर देन मोड z 8.05, क्रिटिकल वैल्यू से मोड z ग्रेटर देन मिल रहा है, तो at 5% of level null hypothesis is rejected। so उसका मतलब क्या हुआ कि the two populations have not the same mean although they have the same standard deviation। standard deviation दोनों populations के इक्वल है पर उसके मीन इक्वल नहीं है। हम सैंपल मीन और सैंपल स्टैंडर्ड डेविएशन और सैंपल साइज के बेस पे हमने ये बता दिया कि उनके पूरे पॉपुलेशंस के मीन इक्वल नहीं है एट हाई लेवल ऑफ सिग्निफिकेंस। ओके, now second example, the mean of sample of size 1000 and 2000 are 67.5 and 68 semi respectively। दो डिफरेंट सैंपल्स दिए हैं n1 and n2। ओके, दोनों लार्ज सैंपल हैं और उसके मीन दिए हुए हैं। कैन सैंपल्स बी रिगार्डेड वन फ्रॉम द सेम पॉपुलेशंस ऑफ स्टैंडर्ड डेविएशन 2.5। ओके, और यहाँ भी यही मतलब वो दोनों पॉपुलेशंस इक्वल पॉपुलेशंस में से लिए गए हैं, ऐसा हमें वेरीफाई करना है। तो पहले तो जो डेटा दिया हुआ है n1 n2 x1 बार x2 बार एंड सेम पॉपुलेशन, सो सिग्मा 2 स्टैंडर्ड डेविएशन ऑफ पॉपुलेशन सिग्मा इज इक्वल टू 2.5 सेम। अब क्या है, कैन द सैंपल्स रिगार्डेड ड्रॉन फ्रॉम द सेम पॉपुलेशन। तो मतलब अगर स्टैंडर्ड डेविएशन और स्टैंडर्ड मतलब मीन दोनों इक्वल होते हैं तो सेम पॉपुलेशन से लिया गया है। तो यहाँ क्या होना चाहिए, मीन इक्वल है तो मतलब द सैंपल्स हैव बीन ड्रॉन फ्रॉम द सेम पॉपुलेशन ऑफ स्टैंडर्ड डेविएशन 2.5। अल्टरनेटिव क्या होगा कि नहीं, दोनों इक्वल नहीं है। ओके, एंड अल्फा इज इक्वल टू 0.05 टेस्ट स्टैटिस्टिक। अब यहाँ पे सिग्मा सिग्मा 1 और सिग्मा 2 की जगह सिग्मा दोनों के लिए सिग्मा ही है, तो सिग्मा 1 सिग्मा 2 मतलब वो सिग्मा ही मिलेगा क्योंकि दोनों के लिए सेम पॉपुलेशन का स्टैंडर्ड डिवीजन इक्वल दिया है। तो x1 बार माइनस x2 बार अपॉन अंडर रूट सिग्मा स्क्वायर अपॉन n1 प्लस सिग्मा 2 स्क्वायर अपॉन सिग्मा स्क्वायर अपॉन n1 प्लस सिग्मा स्क्वायर अपॉन n2। तो मुझे मिलेगा माइनस 5.16। सो मोड z 5.16। क्रिटिकल वैल्यू 5% ऑफ लेवल ऑफ सिग्निफिकेंस। ओके, नहीं दिया है तो 5% लेवल 1.96। यहाँ पे मोड z ग्रेटर देन मोड z, तो उसका मतलब क्या हुआ कि द नल हाइपोथेसिस इज रिजेक्टेड एट हाई लेवल ऑफ significance, that is the sample cannot be regarded as drawn from the same populations of standard deviation 2.5 centimeter। Okay, now example number 17, in IPL the average of runs of score by Chennai Super King in 50 matches is 175 with standard deviations 30, while that of the Mumbai Indians in 60 matches is 165 with standard deviations 25। Test at 1% level of significance whether Chennai Super King perform better than Mumbai Indians। Okay, so this is the question। Okay, so first of all, what we have given N1 and N2, 50 matches for Chennai Super King and 60 matches for Mumbai Indians. So this is our sample N1 and N2, and 175 average run. So samples mean x1 175 and for x2 bar we have 165 and standard deviations for s1 which we have given 30 and s2 is 25। हमें क्या टेस्ट करना है कि अब इन दोनों के मीन इक्वल मिलते हैं। अगर मीन इक्वल मिलेंगे तो हम कह सकते हैं देयर इज नो सिग्निफिकेंट डिफरेंस बिटवीन द परफॉर्मेंस ऑफ चेन्नई सुपर किंग्स एंड मुंबई इंडियंस। ओके, तो अल्टरनेट हाइपोथेसिस क्या होगी, म्यू वन ग्रेटर देन म्यू टू। अगर μ1 > μ2 मिलता है। μ1 किसके लिए लिया हुआ है हमने, x1 n1 मतलब 50 मैचेस। अगर चेन्नई सुपर किंग्स ग्रेटर देन, मतलब उसका मीन ग्रेटर देन रन ऑफ मीन विच इज ग्रेटर देन मुंबई इंडियंस, देन हम कह सकते हैं कि चेन्नई सुपर किंग परफॉर्म बेटर देन मुंबई इंडियंस। तो अल्टरनेटिव हाइपोथेसिस ये होगी, एक्सेप्टेड होगा 1% लेवल ऑफ, अगर चेन्नई सुपर किंग परफॉर्म बेटर देन मुंबई इंडियंस। सो इफ वी गेट μ1 greater than μ2, then we get this alternate hypothesis. And equal null hypothesis, we consider there is no significant difference between the performance of Mumbai Indians and Chennai Super Kings. और हमें टेस्ट करना है whether the Chennai Super King perform better than Mumbai Indians. So here alternative hypothesis I get μ1 greater than μ2 if I get, so ये रिजेक्शन के लिए मतलब नल हाइपोथेसिस हम एज्यूम करते हैं। अल्टरनेटिव हाइपोथेसिस मुझे मिलेगी μ1, अगर μ1 greater than μ2, then ये नल हाइपोथेसिस रिजेक्ट होगी अगर μ1 greater than μ2। So this is my alternate hypothesis. Okay, level of significance is 0.01. Test of statistics said here x1 bar minus x2 bar upon under root s1 square upon n1 plus s2 square upon n2. Okay, and if we put all this value, what I get 1.88. So mod z is 1.88. Now critical at 0.01, 2.33. So mod z, which is less than z.01, so null hypothesis is accepted at 1% level of significance. मतलब कि null hypothesis accepted, it means alternative hypothesis is rejected. Now alternative hypothesis is rejected, it means the Chennai Super Kings do not perform better than Mumbai Indians. Here μ1 greater than μ2, it means Chennai Super Kings perform better than Mumbai Indians. So alternative hypothesis is rejected here. So the Chennai Super Kings do not perform better than the Mumbai Indians. Okay. Now example number 18. Samples of heights of 4,000 Chinese soldier has a mean of 168 centimeter and standard deviations of 4 centimeter. While a sample of heights of 2,000 Indian soldier has a mean of 170 centimeter and standard deviations of 8 centimeter. Do the data indicate that the Indian soldier are, on the average, taller than the Chinese soldier at one level of significance? ओके, तो यहाँ 4,000 सोल्जर पहला सिंपल है वो दिया हुआ है एज ए चाइनीज 4,000 सिंपल ऑफ चाइनीज सोल्जर का, और दूसरा 2,000 इंडियन सोल्जर। तो N1, ओके, हम N1 जो इंडियन सोल्जर उसको N1 कंसिडर कर रहे हैं और चाइनीज सोल्जर को N2 रह रहा है। तो x1, the mean of Indian soldiers height is 170 and x2 is 168. Chinese soldier height, mean of Chinese soldier height, and standard deviations for Indian soldiers we have 8 centimeter and for Chinese soldiers we have 4 centimeter. Now do the data indicate that the Indian soldiers are on average taller than the Chinese soldier at one level of significance? This is the test of significance. So now if we consider this μ1 and μ2, okay, whole Chinese soldiers mean heights and whole Indian soldier mean height both are equal, then we can say there is no significant difference in the height of Indian soldiers and Chinese soldier. Now alternative hypothesis क्या होगी? Alternative hypothesis that Indian soldiers are on average taller than the Chinese soldier. तो मतलब कि इंडियन सोल्जर्स को हमने हाइट का मीन कहाँ पे है हमारा? ओके, सो यहाँ पे x1 हमने n1 और x1 लिया हुआ है इंडियन सोल्जर के लिए मीन सैंपल और हाइट। तो उसका μ1, अगर μ1 ग्रेटर देन μ2, वो हमारी अल्टरनेटिव हाइपोथेसिस होगी, μ1 ग्रेटर देन μ2। अगर वो सेटिस्फाई, अल्टरनेटिव हाइपोथेसिस मतलब कि जो पूछा गया है वो सेटिस्फाई यहाँ पे हो रहा है, इंडियन सोल्जर्स आर ऑन एवरेज टॉलर देन द चाइनीज सोल्जर्स, सो μ1 ग्रेटर देन μ2। तो नल हाइपोथेसिस हमने जो भी पूछा है उसके रिजेक्शंस के तौर पे ले रहे हैं। तो μ1 equal to μ2, there is no significant difference in the height of the Indian soldier and Chinese soldier. Now alternative is μ1 greater than μ2. Yes, this is the right tell, μ1 greater than μ2. Right, okay, in previous one, yeah, this is right tell. Why? Right tell test. Yes, of course, because see, alternative hypothesis is a complement of a null hypothesis, and null hypothesis is mean generally we assume as a rejections of our claim, and our claim is that do the data Indian soldiers are on the average taller than the Chinese soldier. So Indian soldiers we have considered sample as n1 and mean as x1. So is a populations mean we call it μ1. Okay, now which is greater than Chinese soldiers mean? Greater than mu2. It means our alternative hypothesis accepted. Okay, right tail answer. Okay, you are just answering. Fine, good. Now level of significance 8.01. टेस्ट ऑफ यहाँ सिंपल डेविएशंस दिए हुए हैं. ओके, तो यूज होंगे सिंपल में. और जेड मुझे मिल रहा है 11.11. मोड जेड इज ऑल्सो 11.11. क्रिटिकल वैल्यू 8.01, 2.33. मोड जेड ग्रेटर देन. So null hypothesis is rejected at one level of significance. It means alternative hypothesis is accepted. So हम क्या कह सकते हैं कि the Indian soldiers are on average taller than Chinese soldiers. Okay. Now the test of significance for difference of standard deviations for large samples. Okay, difference of standard deviations. पहले हमने इसके पहले जो डिस्कस कर रहे थे एग्जांपल which is a difference of a mean. So here's difference of a standard deviations. S1 and S2 be standard deviations of two independent large random sample with size n1 and n2. Okay, where n1 and n2 greater than or equal to 30. Greater than 30. Okay, drawn from two populations with standard deviations sigma 1 and sigma 2. Now working rule. तो यहाँ पे अब हम डिफरेंस ऑफ स्टैंडर्ड डेविएशंस की बात कर रहे हैं. तो अगर इक्वल है तो हम कह सकते हैं कि टू सैंपल्स हैव बीन ड्रॉन फ्रॉम द टू डिफरेंट populations having same standard deviations. ओके, उसके मीन की बात नहीं कर रहे. हमने दो डिफरेंट सेम पॉपुलेशंस के सेम स्टैंडर्ड डेविएशंस है. नल हाइपोथेसिस इस तरह से आएगी. और अल्टरनेटिव μ1 सिग्मा 1 नॉट इक्वल टू सिग्मा 2 और सिग्मा 1 लेस देन सिग्मा 2 और सिग्मा 1 ग्रेटर देन सिग्मा 2. ओके, level of significance alpha test statistic. There is again two cases when the population standard deviation sigma 1 and sigma 2 are known, and S1 minus S2. Now see here in this difference of standard deviations in numerator I get S1 minus S2. In previous case we get x1 bar minus x2 bar. Okay, so here from the example you get the idea which statistic you have to use. So here S1 minus S2 upon under root sigma 1 square upon 2n1 plus sigma 2 square upon 2n2. In the population standard deviation sigma 1 and sigma 2 are not known, and z is equal to S1 minus S2 upon under root S1 square upon 2n1 plus S2 square upon 2n2. Where S1 and S2 are simple standard deviations, critical value z alpha of z at given level of significance. Now mod z less than z alpha at level of significance alpha, the null hypothesis is accepted, and mod z greater than z alpha at level of significance alpha, the null hypothesis is rejected. Okay, so all these rules are the similar. Just z statistic, we have a different formula. Now, what we have given in example, the standard deviations of random sample of 1000 is found to be 2.6, and the standard deviations of another random sample is 500 is 2.7. Assuming the sample to be independent, find whether the two samples could have come from the population with same standard deviation. तो यहाँ हम same standard deviations की बात कर रहे हैं. तो मतलब ये हमारे जो इसमें पहले तो जो सैंपल दिए हैं n1 n2 1500, उसके S1 और S2 स्टैंडर्ड डेविएशन दिए हैं 2.6 एंड 2.7. अब नल हाइपोथेसिस हम क्या बात कर रहे हैं कि सिग्मा 1 इक्वल टू सिग्मा 2. यहाँ पे with find whether the two samples could have come from the populations with the same standard deviation. So sigma 1 is equal to sigma. There is no significant difference between two standard deviations. तो alternative होगी there is a significant difference in two standard deviations of a populations. Okay, level of significance alpha is 0.05, and now the test statistics z is equal to s1 minus s2 upon under root s1 square plus s2 square s1 square upon 2n1 plus s2 square upon 2n2. और सिंप्लीफिकेशन के बाद मुझे मिलेगा वो माइनस 0.97. सो मोड z is 0.97, critical value 1.96. so we can say that mod z less than absolute value at z.05. so null hypothesis is accepted at high level of significance. Accepted, it means there is no significant difference between two standard deviations in two sample would have come from the population with same standard deviation. Okay. Now example number 20. Determine whether the two samples for which the data are given in the following table would have drawn from the population with same standard deviation. सेम स्टैंडर्ड डेविएशन की बात कर रहे हैं। ओके, तो फिर और यहाँ पे साइज और स्टैंडर्ड डेविएशन दिया है S1 एंड S2 सैंपल के लिए, N1 एंड N2 100 एंड 200 एंड S1 एंड S2 5 एंड 7। तो नल हाइपोथेसिस दोनों इक्वल है, पॉपुलेशन स्टैंडर्ड डेविएशंस इक्वल, two samples could have been drawn from the population with same standard deviation. Alternative hypothesis sigma 1 not equal to sigma 2. So alpha here we haven't given, so consider 0.05 and z which I get now minus 4.02. So mod z is equal to 4.02 and now critical value 1.96. So mod z greater than mod z at 0.05. So null hypothesis is rejected at high level of significance. These two samples could not have been drawn from the population with the same standard deviations. Okay. So here we have completed a large sample test. Okay. Now we are going to be discuss. So what we have discussed in this unit, whole unit, we have discussed this large sample test for single proportion, difference between two proportions, single mean, and today we have discussed difference between two means and difference of a standard deviations. Okay, so large samples we have completed. Now small samples. In small samples we have three different tests: t-test, f-test, and chi-square test. So now we are going to be discuss small sample. Small sample, it means n, your sample n which is less than or equal to 30. Okay, so we discuss test of significance for single mean, difference of means, and correlation coefficient. Okay, so these are the remaining unit now. Okay, t-test, f-test, and chi-square test. So for small sample, we have three different tests: student t distributions, Sennender's f distributions, and chi-square distributions. So these three different tests we are going to be discussed. So first one is student t distributions. Okay. Uh, t is equal to difference. Okay, t is equal to difference of populations parameter and corresponding statistics upon standard error of the statistics. So this is our t. And with n minus 1 degree of freedom if sample size is n. Now here degree of freedom, what it means degree of freedom, it means suppose you have an n number of observations, okay, and you have some k constraint, then degree of freedom v is equal to n minus k. For example, you have any 5 observations and there is no restriction on these 5 observations, then your degree of freedom is 0. Sorry, n minus k. K is, there is no constraint. There is no constraint. It means your degree of freedom is n. But suppose you have 5 observations, and if you say that some of these 5 observation is 100, some of these 5 observation is 100, it means that you can choose four four observations as independently, but now you have to choose fifth observation in such a way so that the sum of all 5 observations must be 100. So it means your uh, four observations are independent, but one is dependent on remaining four. So your constraint is one here. Okay, so here we whatever we are going to be discuss the example in which we have a constraint one. So our degree of freedom is n minus one for sample size n, and x1, x2, xn be the random sample of size n, n less than equal to 30 drawn from the normal populations with mean mu and standard deviation sigma, then student t statistics is defined as t is equal to x bar minus mu upon root n, और अगर s दिया हुआ है तो x bar minus mu upon s upon under root n minus 1. Okay, where x is sample, x bar is sample mean, s is under root x minus x bar whole square upon n is unbiased estimate of sigma square. The test statistic t is equal to x bar minus mu upon s upon under root n minus 1 is a random variable having t distributions with n minus 1 degree of freedom. And with probability density functions, okay, that is not, it's not so much importance, but whatever here continuous distribution, so there it has a probability density functions, and v is, so this is f of t is equal to c into 1 plus t square upon v raised to minus v plus 1 by 2, and for that we have this v is n minus 1 and c is constant, so which is not as much important in example point of view, but you have to be understand that, like, you have some distributions then which have some probability density functions, or if continuous distribution then probability density functions. And here we have sample size which is less than or equal to 30, population standard deviations is not known. Now assumption for t-test, that assumptions drawn are from normal populations and are random. Okay, normal it means or normal distributions, continuous distributions, and for that is for t distributions we have this f of t probability density functions. This is our first assumptions, and second assumptions is population standard deviations may not be known. Okay, population standard deviations या तो दिए हैं या तो नहीं भी दिए होते हैं. Testing the equality of two populations mean the population's variance are regarded as equal. And in case of two samples, some adjustments in degree of freedom for t are made. So these are the assumptions. Now property of t distributions. So for a property, t distribution is asymptotic to x-axis. It means which extend to infinity on the either side, both the sides of a x-axis. Second, t distribution is symmetric about the mean, shape of the curve varies with the degree of freedom. Okay, and the larger number of degree of freedom, the more closely to t distributions resemble standard normal distributions. And sampling distributions of t does not depend on the population's parameter, but it's depend only on the degree of freedom v, that is on a sample size. Okay, so this is the graph of distributions. Okay, f of t and t, which is a normal curve, and see here mean which is on x-axis, and which and extend on infinity on both the sides. Okay, of x-axis. Now application of t distributions to test the significance of sample mean when the population's variance sigma is not known. Second, to test the significance of mean of the sample, that is to test if the sample's mean differs significantly from the population mean. So these are the applications here. क्या क्या टेस्ट कर सकते हैं? टेस्ट ऑफ सिग्निफिकेंस ऑफ अ सैंपल मीन व्हेन द पॉपुलेशंस वेरिएंस सिग्मा इज नॉट नोन. We can test of significance of mean of the sample, that is to test if the sample mean differs significantly from the population mean, and to test the significance of difference between two sample mean, the population's variance being equal and unknown, and to test the significance of observed sample correlation coefficients. Okay, so first, now test of significance for a single mean. Okay, as here suppose you have x1 x2 xn be a random sample of size n where n less than equal to 30. Okay, so ये x1 x2 xn random sample है for normal populations with mean mu and standard deviation sigma. If the sample mean x bar differs significantly from the population's mean mu, that the standard student's t statistics is given by t is equal to x bar minus mu upon s upon under root n minus 1, where s is, we know that, under root x minus x bar whole square upon n, and v is degree of freedom n minus 1. So confidence limit here 95% confidence limit, we have formula x bar plus or minus t at 0.05 and s upon under root n minus 1, where t at 0.05 is a 5% critical value of t, for v is equal to n minus 1 degree of freedom for the true tail test, and 99% confidence limit, it means x bar plus or minus t 8.01 s upon under root n minus 1, that is 1% critical value of t at for v equal to n minus 1 degree of freedom for the true tail test. Okay, now example. So the mechanist is making engine part with axle diameter of 7 centimeter, a random sample of 10 parts. Okay, let's see. Now the sample n is equal to 10, which is less than 30. Shows a mean diameter of 0.742 centimeter with the standard deviations 0.04 centimeter. Compute the statistics you would use to test whether work is meeting the specification at 0.05 level of significance. Okay, not percentage here, 0.05 or 5% level of significance. Solutions. So n is equal to 10. We have given one sample only. X bar for sample we have given mean diameter is 0.742, and the population diameter we have given zero point 0.7. So mu we have given 0.7 centimeter, and standard deviations for sample we have given 0.04. Now what we have to say? Compute the statistic you would be used to test whether work is meeting at the specification. It means mu is equal to 0.07. Okay, the our specification is a mechanic making engine parts with axle diameter of 0.07 centimeter. So mu equal to 0.77. The product is meeting the specification. Alternative, mu not equal to 0.07. Level of significance alpha is 0.05. Now test statistic t. So for that we have x bar minus mu upon s upon under root n minus 1. So x bar is 0.742 minus zero point 0.7 upon 0.04 upon under root 10 minus 1. So what we get, t is here 3.15. Okay, after completing. Now t bar, so which is 3.15. Critical value. So n we have given, degree of freedom we have n minus 1, so which is 9. So I have to find out at 5% level of at, so value of t at 0.05 with degree v equal to 9, and now I have to show you a t table. Okay, so for that I have to show you a t table in which, see what we have given here. We want to find out the value of t with degree of freedom 9 at 0.05. So in table, okay, now see this is t table, and here we have given degree of freedom 9. Okay, and 0.05. So 0.05 is here. This is 0.05. Okay, for one tail test. Now two tail test. We have a two tail test. So 0.05 is here. Okay, for two tail test, 0.05 is here, and 9 of degree freedom. So we want to find out number this, and v is equal to 9, and for two tail test level of significance is 0.5. So I get this value, this one, 2.262. Okay, this one 2.262. Okay, so now in example 2.262. Okay, 2.262. So if you compare with this mod t greater than at t at 0.05 with degree of freedom 9. So null hypothesis is rejected. So this product is not meeting the specification. Okay, from the sample we can say that this whole populations which not have making an engine for that which have diameter 0.7 centimeter. Now the mean lifetime of the sample of 25 bulbs is found as 1550 hours with a standard deviations of 120 hours. The company manufacture the bulbs claim that the average life of their bulbs is 1600 hours. Is the claim acceptance at high level of significance? Okay. So first of all, what we have given? We have given sample n is equal to 25, and for that Mean is 1500 hours lifetime of the sample. Okay, bulb, lifetime of the bulb. And standard deviations, yes, which we have been 120 hours. And now average life of the manufacturing bulb of a company is 1600 hours. Mu we have given, okay, for whole manufacturing. Is claim acceptance at high level of significance. So mu is equal to 1600 hours. That is first our null hypothesis. Average life of bulb is 1600 hours. Alternative hypothesis, if which is greater than, then it is accepted. If greater than, more than 1600 hours, if life we get, then it is accepted. So alternative hypothesis is a complementary of null hypothesis. So if your mu which is less than 1600 hour, then I can say that this null hypothesis is rejected. If we get more than 1600 hours, then it is accepted. Okay, so definitely alternative hypothesis, which is here we get one tail test mu less than 1600. Alpha is 0.05, and now third statistic, x bar minus mu upon s under root n minus 1. So if we put this value, what I get, t minus 2.04. So mod t is 2.04. Critical value v is equal to n minus 1. 25 minus 1 is equal to 21. Now this value we want to find out in table, t 0.05. Okay, now this is at v equal to 24. In table, if you see v equal to 24 and one tail test, it means you get here one tail test 0.05, 24. So what you get, this number 1.711. Okay, 1.711. Okay, let us see. Yeah, 1.711. Now what we can say, which is mod t greater than. So the null hypothesis is rejected at high level of significance. That is, the average life of bulbs is less than 1600 hours and the claim is unacceptable. Okay. Example number 23. Soaps manufacturing company was distributed a particular brand of soaps through a large number of retail shops. Before a heavy advertisement campaign, the mean sales per week per soap was 140 dozens. After the campaign, the sample of 266 soaps was taken and the mean sales was found to be 147 dozens with standard deviation 16. Can you consider the advertisement effective? Okay, so first of all, what we have given here, we have given a soap manufacturing company was distributing particular brand of soap through a large number of retail shops, and before having advertisement campaign, the mean sales per week soap was 140 dozens. After the campaigning, before the campaigning and after the campaigning, okay, after the campaigning, sample of 266 soaps was taken and the mean sales was found to be 147 dozens with standard deviations 16. So can you consider this advertisement is effective? So before and after, and here we have given 26, not uh, 226. Here there is a correction, sample of 26 soaps, not 220, 266. Otherwise, which is a large sample. So here there is a correction, uh, 26 sample. Okay, 26 soaps. There is a correction here. We have a 26 soaps. In X bar is equal to 147. So for this sample, we have 147's mean of cells. Okay, cells found to be 147 dozen with standard deviations 16. So S is equal to 16 dozen. And for whole populations, we have given before advertisement 140 dozens. Okay, so before advertisement we have 140 dozens. After advertisement we have taken a sample, and n is equal to 26, and then we get the mean and standard deviations is 147 and 16 dozens. So null hypothesis mu is equal to 140 dozens. It is advertisement is not effective. Okay, if we get the mu is equal to 140 dozens, and if we get the more than 140, then we can say that advertisement is effective. Okay, so alpha is equal to 0.05, t is equal to x bar minus mu upon s upon under root n minus 1. After putting value, we get 2.1875. So more t is m. Now we n minus 1, n given 26. So I get t at 0.25. Now we see in this table, see this is one tail test and at 0.05, and we which we have degree of freedom 25. So one tail test, first of all, this is one tail test 0.05 and 24. We what we have 25, 25. So 1.708. We must have to get 1.708. Yes, 1.708. Now more t greater than t at 0.05. So null hypothesis is rejected at high level of significance. That is, the advertisement is effective. Now example 24. Random sample of 10 boys had the following IQs: 70, 120, 100, 10, 101, 88, 83, 95, 98, 101, and 100. And do this data support the assumptions of population's mean IQ of 100? And second questions we have asked, find 95% level confidence limit for the mean IQ. So support for the random of sample of 10 boys of IQ which we have given. So we can find out the mean from the given data. Okay. So which mean we get 97.2 as sum of all this data and divide by 10. So we get this 97.2, and standard deviations sample you also calculate, which you get this. You have already formula under root x minus, okay, this which we have discussed, x minus x the whole square upon n of, okay, this. So s which we get here 13.54. So these things x bar and s which we have to calculate from the data. Now does the data support the assumptions of the population's mean IQ of 100? So first we consider null hypothesis mu is equal to 100. The population has mean IQ of 100. Okay, and then alternative hypothesis h1 mu not equal to 100. So two tail hypothesis. Okay, alternate hypothesis here mu not equal to 100, and level of significance alpha is x minus mu upon s upon root n minus 1. X bar we have given, mu we have given, small s we have given, n we have given. And if we put all this value, t is equal to minus 0.662. So absolute value we have found out. Now degree of freedom is 9. So t at 0.05 with v degree of freedom n equal to, and which is for two tail. Okay, so first let us see what I get is for two tail 0.05 here, and degree of freedom what we have given, degree of freedom is 9. So two tail zero point 0.5 and 9, what I have to get here 2 point 2.262. Okay, 2.26. Two for degree of freedom 9, and two tail test is 2.622. So let us see what we get. Yeah, 62. So more t less than at t point 8.05. So null hypothesis is accepted. Of significance, that is population has mean IQ of 100. Now also second thing we have to say that find the 95% confidence limit. Okay, the given mean IQ and we have formula this is equal to plus or minus t 0.05 s upon under root n minus 1, so which you get 87 and 1.41. So after calculate you get this. So this is example number 24. So now we move for example number 25. The height of 10 male of a given locality are found to be 175, 168, 155, 170, 152, 170, 175, 160, 160, and 165 centimeter. Based on this sample, find the 95% confidence limit of the height of the male. Okay, again we have to say that find out the confidence in limits, and whatever we have given from that you can find out x bar and degree of freedom v is equal to n minus 1. And from t table you can say that this is nothing but 2.6. Now you already know how to find out the value from the t table. And then confidence limit, which we require x bar minus t at s upon under root t n minus 1. If you put this, what I get 159 170.73. So the heights of male in locality are to be in limits 159.27 and 170.73. Okay, so here we have completed for a single mean. Okay, student t-test. Test of significance for a difference of a means. So for that you have given two independent sample of size n1 and n2, which is less than 30, less than or equal to 30, and here random variable which we call it x1, x2, xn, and y1, y2, yn, with standard deviations s1 and s2 from the normal populations with mean mu1 and mu2, and the same standard deviations of a set of the given populations. Okay, so students, t statistics given by here x bar minus y bar upon s into under root 1 upon n1 plus 1 upon n2, and with degree of freedom v, which we can say that n1 plus n2 minus 2. So x bar is equal to summation xi upon n1 and y bar is summation yi upon n2, and s is under root summation x minus x bar whole square plus y minus y bar whole square upon n1 plus n2 minus 2. So this is the formula for x bar. It means mean of this random variable x1, x2, xn, and y bar is mean for the random variable y1, y2, yn. S is the sample deviations. Okay, so this is summation x minus x bar square plus y minus y bar square upon 1 plus n2 minus 2 under root of this, for which we get the sample deviations. And in terms of standard deviations s1 and s2, t is equal to x bar minus y bar s into under root n1 n2. Okay, where s, if you have given two different sample deviations, then you can calculate s as under root n1 s1 square plus n2 s2 square upon n1 plus n2 minus 2, and where s1 and s2 you already know how to find out under root summation x minus x bar square upon n1, and s2 is summation y minus y bar whole square upon n2. Then if n1 and n2 are, and if both the sample have the same sample size and samples are independent, that is the observation in two samples are not all related, then t statistics is given by under root s1 square plus s2 square upon n minus 1 with v is equal to 2n minus 2. Okay, here n, instead of n1 and n2 we have both have n, so n plus n, 2n minus 2. Pair of value of x and y are associated or correlate in some way or not independent. The above formula for testing of hypothesis cannot be used, as di is equal to xi minus yi. We get the difference, okay, here of value of x and y for the ith pair. So we have to find out di, and then t is equal to d bar upon, so mean of this di upon s upon root n minus 1 with v is equal to n minus 1. D bar and s denote the mean and standard deviation of difference di respectively. So this d bar is summation di upon n, s is under root s summation di minus d bar whole square upon n. A lot of formula you have to be remember here. Okay, confidence limits is 95%. x bar minus y bar plus or minus t at point 0 into 1 upon s into under root 1 upon n1 plus 1 upon n2. And for 99, instead of point you have at point 0 1, t at point 0 1. Okay, you for 10 degree of freedom same in 1 plus into number 26. Random samples of size 9 and 7 are given 196.42 and 198.82. The sum of the square of the deviations from are sum of the square of the deviations from the mean are given 26.94 and 18.2 respectively. Can the sample be considered to have been drawn from the same populations? So first of all, what we have given? We have given N1 and N2, 9 and 7, two different samples, which X bar and Y bar is 196.42. Mean of these two X bar and Y bar, which we have given, and then square of the standard deviations. Sum of deviations. Deviations, it means deviations from the mean X bar, and sum of square. So sum of square of which is 26.94, and for second sample we have 83. So first of all we calculate S. S is sum of these two deviations upon n1 plus n2 minus 2. Calculating what I get 1.806. So null hypothesis H0 is equal to mu1 equal to mu2. That is, the samples are drawn from the populations, same populations. Okay, and alternating hypothesis that which have a not the same mu1 not equal to mu2, which is not same mean. Okay, simple are different. The level increment is alpha is equal to 0.05. Now t, which we can calculate, so as we have already calculated s here, so t is x bar minus y bar upon s into under root 1 upon n1 plus n1 upon n2. Okay, and as we know that s, how do we calculate s? Okay, here, so all this value we have, we can put in this z t statistics, and what I get here minus 2.6368. So mod t 2.6368. Now degree of freedom, v is equal to n1 plus n2 minus 2, so which is 14. Okay, 9 plus 7 minus 2, 14. So t at level of significance we haven't given, so we consider assume as 0.05, and which I get, see from the table, this is two tail test. Yeah, once again I show you this table, two tail test 0.05, and what we have given, degree of freedom is 14. Okay, so 14 or 24, yes 14. So 14, what I get, 2.125, 2.125. Okay, 2.125, yes. Now if we compare, then we know that mod t greater than t at 0.05. So the null hypothesis is rejected at 5% level of significance. Okay, that is, the samples are not drawn from the same populations. Now example number 27. The mean height and standard deviations height of 8 randomly chosen soldiers are 166.9 semi and 829 centimeter respectively. The corresponding value of 6 randomly chosen sailors are 170.3 centimeters and 850 centimeters respectively. Based on this data, can we conclude that the soldiers are in general shorter than sailors? Okay, first of all, what we have given? We have given two random sample, n1 is equal to 8 soldiers and n2 is equal to 6 sailors. And for soldiers, which we have a mean height is 166.9 centimeters, and for sailor mean height is 170.3 centimeters. We have also given the sample standard deviations. S1 is 8.29 centimeter and S2 is 8.50 meters. Now from S1 and S2 we can calculate S. Okay, we can calculate S here. So which I get here formula whenever you have given S1 and S2, then N1 plus N2 plus N2 S2 square upon N1 plus N2 minus 2. Okay, and this is 9.05 meter. So null hypothesis is mu1 equal to mu2. That is, there is no significant difference between the height of soldiers and sailors. Okay. So what we get alternative hypothesis, can we conclude that the soldiers are in general shorter than sailors? So soldiers, which is mean of the soldiers height is mu1. So mu1 less than mu2. Okay, then which is our alternate hypothesis. Okay, and here we are saying that mu1 equal to mu2. There is no significant difference between height of soldier and sailor. And null hypothesis always assume for a rejection. So alternative hypothesis is whatever here we have given, which is accepted, and this is mu1 less than mu2. Okay, so one tail hypothesis, level of significance which we have not given. So consider test statistics, which we can calculate minus y bar upon s into under root 1 upon n2, and which I get minus 0.696. So 0.696. Now degree of freedom 8 plus minus 2. So we so T 8.05 for one tail test, and degree of freedom is 12. Okay, so which I get 1.782. Now you know that how to find out from the table. So I am not showing right now. Okay, and so what we can say that mod T less than T 8.05, the null hypothesis is accepted at 5% level of significance. That is, we cannot conclude that the sailors are in general shorter than okay sorry soldiers are in general shorter than sailors. So here, so there is correction. We have soldiers are in general shorter than sailors. Okay, and data represents the biological value of protein from the cow's milk and buffalo's milk at certain level. So cow's milk, which 1.82, 2.02 protein value. Okay, for different sample we have this 1.88, 1.61, and like this similar manner. Buffalo from buffalo milk protein samples we have given biological value of protein which we have given here. So total number of 6 samples from uh, cow's milk and buffalo milk which we have done. N1 and N2 both are equal here, but independent. Both are independent. Okay. So let us see. Examine if the average value of protein in two samples significantly differ. Solutions. What I get here: n is equal to 6, x1 bar is equal to 1.78, x2 bar is equal to 1.965, s1 is equal to 0.16, and s2 is equal to. So we have to calculate this x1 bar, mean of this value. Okay, sum of all this divide by 6, sum of all this divide by 6, so you get x1 and x2 bar. In similar manner, once you get x1 bar and x2 bar, you can also find out the standard deviations. Okay, as you know that all the formula for that. So you can find out S1 and S2. You have to calculate this value first of all. Once you get this, we consider here null hypothesis. H0, it means mu1 equal to mu2 for whole populations. Okay, so in general, there is no significant difference in average value protein in two milk. Okay, samples, cow's milk or buffalo milk. No significant difference. Now, if there is difference, then we call it alternative hypothesis. So level of significance here 0.05. Test statistics x bar minus y bar upon s1 square plus s2 square upon n minus 1. See, I have suggested if you have n1 equal to n2 and both the samples are independent, then we have this formula, okay, which we have already discussed. So this x bar minus y bar. Here we need to be required to be calculate s. So x bar minus y bar upon under root s1 square plus s2 square upon n minus 1. And what I get here, minus 2.043. So mod t is equal to 2.043, and critical value, this is both the sample which have 6. So 2 into 6, 12, minus 2, 10. Now to tell test, so we have to find out t at 0.05, v equal to 10, so 2.228. Okay, so listen here, mod t less than at 0.05. So we can say that the null hypothesis is accepted. Okay, null hypothesis is at high level of 5% level of significance. That is, there is no difference in average value of protein in samples. A certain injection administered to 12 patients resulted in rapid change of blood pressure. Okay, 2, 5, 5, 2, 8, minus 1, 0, 6, minus 2, 1, 5, 0, 4. So this is the difference in blood pressures. Can it be concluded that the injections will be in general accompanied by an increase in blood pressure? Okay, so first of all, from the sample we have given a change d is equal to x minus y in blood pressures are given. Okay, this change in a blood pressures. So final blood pressures after administering injection, y is the initial blood pressure. It is required to calculate whether the mean blood pressure has increased after injecting. Okay, for a given 12 patients. So there is a mu1, that is mu1 greater than mu2. Okay, obviously mu1 is greater than mu2. This is mu1, which represents uh, mean of the blood pressures before injected, and mu2 represent the mean of the after injecting. Okay, the blood pressures. So here n is equal to 12. We have given summation di, which I get 31. If you find out this summation of all this value, which you get 31, and then take the square of all this and find out the summation of this, then summation di square you get 185. Okay, square of sum of all this, which is 185. Now d bar, we need to find out d bar here. So summation di upon n, 2.58. Now s, which we can calculate, under root summation di square upon n minus summation di upon n whole square. So which we get 2.96 here. Okay, so like once we calculate, see, we require to find out here calculate to s. Okay, as we required s in the formula, and for that what we have given a difference. This is the difference of blood pressure. So actually x minus y bar d we have given difference. Okay, once we have given d this, then we required this summation di and di square to be find out s. So that's why we calculate this and d bar. Okay, now d bar we will use in the formula. Okay, so to calculating test statistics. Now null hypothesis h0 is equal to mu1 equal to mu2. That is the mean blood pressure has not increased. Okay, and if it is increased, so I can say that mu1 greater than mu2. So significance point 0.05 we haven't given, so 0.05 by default we consider. Now t is equal to d bar upon s upon under root n minus 1. So 2.58 upon 2.96 upon under root 12 minus 1. Mod is 2.89. Critical value is equal to n minus 1. 11. T at 0.05 equal to 11 is 1.796. Decision mod t greater than t at 0.05. The null hypothesis is rejected at high level percent of significance. That is, injections will in general accompanied by the increase in the blood pressure. Okay, so this is the conclusion. As we have to ask, can it be concluded that the injection will be in general and accompanied by an increase in the blood pressures? and null hypothesis is rejected. So the injection will in general combined by an increase in the blood pressure. Alternative hypothesis is accepted. It means mu1 greater than mu2. Okay, so now t-test, test of significance for correlation coefficients. Okay, so let x1 comma y1, x2 comma y2, and xn comma yn. We have a pair of n random variables samples from the bivariate normal populations and R with the observed correlation coefficients in the sample. So it is required to test if the sample correlation coefficient is significant of any correlations in populations. That is whether the value of the population correlation coefficient sigma is 0 and the observed value of R has arisen due to the of sampling. The student t statistics is t is equal to R minus 2 upon the root 1 minus R square. This formula you have to be remember t is equal to R under root n minus 1 minus R square, and R represents observed R here. Uh, this R either the value of population correlation sigma is 0 and observed value of R be the observed correlation coefficient in the sample. R is correlation coefficient in the sample. Correlation coefficient already know that. Okay, fine. With V is equal to n minus 2. So a random sample of, so you must have to remember this formula t is equal to R under root n minus 2 upon under root 1 minus R square, where V is equal to with V is equal to n minus 2. Okay. Random sample of 18 pair of observations from a bivariate normal populations gives a correlation of 0.3. Okay. Is it the variable are uncorrelated in the populations? So in sample we have given 18.3 and 0 consider sigma rho is equal to variable are uncorrelated, and alternative hypothesis that is rho not equal to 0 and alpha as we consider as 5% level of significance. We calculate r under root n minus 2 upon 1 minus r square r n given. So we get this t is equal to 1.26 now. So critical value n minus 2. Okay, so which is 16 and at t.05 which I get 2.12. So what we can conclude from that, mod t less than at t.05. So null hypothesis is accepted at 5% level of significance. That is the variable are uncorrelated in the populations. Okay, as we have considered null hypothesis, the variable are uncorrelated. So example number 21. The correlation coefficient between income and food expenditures for the sample of 7 households from the low income group is zero point 0.9. Using 1% level of significance, test whether the correlation coefficients between income and food expenditure is positive. Assume that the populations of both variables are normally distributed. Okay, so one level of significance we have to say correlation coefficients of sample n is equal to 7 and r is equal to zero point 0.9 we have given. So first of all, we consider null hypothesis. Rho is equal to 0. There is no correlations between income and food expenditure. Okay, there is no correlation between income and food expenditure. This is our null hypothesis. Alternative hypothesis, rho not equal to 0. So there is a correlations between income and food expenditure. Level of significance is we have seen 1%, so 0.01. Test statistics. So now we have formula t is equal to r under root n minus 2 upon under root 1 minus r square, and after calculating we get t is equal to 4.61. Then we which we get 5. So t at 0.01 we equal to 7. We equal to 5 now. See here there is a correction, we equal to 5. and so value we get 4.032. Okay, let us check is it correct or not. uh, what we have, T8.01 to tell test, and value v is 5. Okay, t is 0.01 to tell test, first 0.01 is here, and v equal to 5. 4.032, 4.032. Yeah, let us check 4.032. So this is a print mistake. Here we have v equal to 5. Okay, now mode t greater than, here at T8.01, so the null hypothesis is accepted at 1% level of significance. There is, okay, not accepted. See, is mode t greater than, mode t greater than, so null hypothesis is rejected. So there is a correction here. Null hypothesis is rejected. So there is two correction here. One is instead of 7, instead of we have 5, and mode then, yeah, mode t, see, like if mode t less than, then accepted. So here mode t01, so not accepted, rejected. At one level of significance, that there is a correlation between income and food expenditure. Okay. Now example number 32. Find the list value of R samples of 18 pair of observations from a bivalent populations, which is significant at 5 level. Okay. So we have find a list value of R in a sample of n we have given 18. R for n equal to 18 will be significant level at 5. So we have here absolute value of R minus 2 upon 1 minus n square greater than t at 0.05 v equal to 16. Okay. Find the least value of R. So we have to comparatively find out this absolute value of R under root n minus 2 upon under root 1 minus R square, which is greater than equal to 2.12. Okay, which we get from the table, and squaring both the sides, so putting n equal to 18, what we get under root 16, it means 4, and this is r square, 1 minus r square, okay, 16, and greater than equal to 4.5, squaring on both sides. Okay, so this is 16r. After simplification, what I get, 16r square greater than 4.5 minus 4.5 r square. So 25 r square greater than equal to 4.5, so r square greater than 0.22, so mod r greater than 0.47. So hence the least value of r is 0.47 numerically. Okay, so instead of uh, testing the significance for here, sometimes you have to ask find the least value of r in sample of 18 pair of observation. Okay, sometimes you have to ask find out the least value of r from the given sample. When in this example, you have given is equal to 18, and the level of significance is 5%. So, and so we have concluded that the least value of r is 0.47. So I think we have completed t-test here. So in today's sessions, we start with a large sample, okay, for difference of means and difference of standard deviations, and then we have discussed the t-student test for a single mean, difference of means, and for correlation coefficients. Okay, so all these things which we have discussed in these sessions. And now see, for exercise purpose, I will upload all exercise and its solutions on your user ID. I think madam have uploaded. Is there in on user ID or not? Okay, so here I am talking.